All right, so I think where we had left off last time was we had we were like working on solving this problem here with substitution, right? So my goal is to first select a variable and an equation to isolate. When doing this, what I want to avoid is having to make fractions. Not that it's a problem to make fractions, but like if I don't have to, why would I want to mess with all that? So I would identify the y in equation 3. To get that by itself, I won't have to divide by anything other than -1, so I can't really create a fraction out of that, which I'm pretty stoked about. So to get the -y by itself, I'm going to subtract 6x and subtract 4z. And then I'll divide everything by -1. And then I'm going to plug that back into equation 1. And then I'm going to also plug it into equation 2. Well, let's call this equation 4, and we'll write it this way. So I'm going to plug 4 into equation 1, and I'll write over here 4 into equation 2. So equation 1, when I plug 4 into that, what I'm going to do is just where the y was, I'm going to be putting 6x plus 4z plus 1. But everything else is going to stay the same. So 4x plus 2, and then instead of the y there, I'm going to write 6x plus 4z plus 1, then plus 3z equals 1. And then I'm going to be plugging equation 4 into equation 2. So again, same idea. Everything stays the same except for the y, which I replace by 6x plus 4z plus 1. I'm now going to go ahead and distribute through. So 2 times 6 is 12. 2 times 4 is 8. 2 times 1 is 2. If I combine like terms, 4x and 12x is 16x. 8z and 3z is 11z. And then I'll get that, move that constant over to the other side. So subtract 2 from both sides. And I get that's equal to -1. So do the same thing over here on this side, but I have to be careful that when I distribute, I'm distributing a -3. But it's the same idea otherwise. Combine my like terms, 2x and -18x is -16x. -12z and 5z is -7z. And then I'm going to add that I'm going to add 3 over to move the constant to the other side. And so these guys are going to act like equations 5 and 6. So what I have now is a 2-variable system. So I can solve this 2-variable system with equations 5 and 6, just like I would have in the previous section. So I can use substitution or elimination here. Which do you guys feel like I should do? It should be screaming at you, one of them being easier than the other. Which one is screaming to you, substitution or elimination?
Elimination.
Elimination, good. Why?
Because 16 minus 6, or negative 16.
Yeah, look, they're ready to cancel each other out. All I have to do is just add straight down. That's like the best case scenario, right? 100% dead on. Good job. So if I just add straight down 16x and negative 16x give me 0.
Bless you.
11 minus 7 is 4. Negative 1 plus negative 11 is negative 12. I divide both sides by 4 and I get z is negative 3. I can now take that and plug that back into either equation 5 or 6. It doesn't really matter. And if I look at the problems, well, like the numbers are pretty crummy either way, so it doesn't really matter to me there. Let's just plug into 6 for the sake of argument. That's going to give me negative 16x minus 7, and then instead of z, I'm going to put in my negative 3. Negative 7 times negative 3 is negative 21. Subtract 21 from both sides. That gives me negative 32. And negative 16 divided by negative 32 divided by negative 16 gives me 2. So I'm going to take that as well as my answer to z and plug that into either equation 1, 2, or 3. It doesn't matter which one I pick. Which one would I pick, though? Well, actually, I would plug it into equation 4 because the y is already by itself, right? That's the one variable I'm looking for. Let's plug it in there. So y equals, and instead of x, I'm going to write 2. And instead of z, I'm going to write negative 3. So we have y equals 12 minus 12 plus 1. So we have just that y is equal to 1. So my answer is 2, 1, negative 3 as the ordered triple. Everybody okay there? So basically you're just doing one substitution to get it down to a 2-variable system, and we use just our 2-variable techniques from there. Preferably, Mr. Kulik, I don't particularly like substitution for 3-variable systems. I prefer elimination. So in a 3-variable system, elimination works basically the same way as a 2-variable system, except we're going to have to do 2 eliminations. So step 1, we're going to create 2 new equations using elimination. We're going to eliminate the same variable from 2 pairs of equations. So I might use 1 and 3 and eliminate the x, and I might use 1 and 2 and eliminate the x. But you got to eliminate the same variable. That creates 2 equations and 2 variables, which I solve just like a 2-variable equation. Let's do an example, or a numeric example to kind of hammer that home. All right. So if I look at this example, again, my goal when doing an elimination is what I want to do is I want to have to do as little multiplication as I can, or as I have to. So the best case scenario is where I see a variable with a coefficient of 1. and I see that for x, y, and z, I have a variable with coefficient 1 in all three places. So it doesn't really matter which variable I eliminate first. It's going to be purely a matter of preference. I'm going to choose to eliminate the x's first because the alphabet. So to eliminate the x's from equation 1, what do I have to multiply equation 3 by? So I have a 3x up here. What do I need to multiply equation 3 by? So when I add them together, they cancel out. -3. That's correct. And then if we do the same thing, so now I want to eliminate the x's from equation 2. What do I need to multiply equation 3 by to eliminate the x's from equation 2? -6. Yeah. So let's write down what we did there. Now the place that's easy to make a mistake is doing the multiplication. You're just forgetting to multiply everything by -3 or -6, depending on the case. That's why if I didn't have to do it, I'd prefer not to have to do it. Or maybe even sometimes just goofing up the multiplication table stuff. So I add down, what do I get? I get -11y minus 11z equals -11. I get -26y minus 17z is equal to -44. Oops-a-daisy. Oh, yeah, okay, that's fine. Okay, so these two we're going to call equations 4 and 5. And equations 4 and 5 form a new system and if I look at the coefficients, they all seem kind of yucky, right? At first glance. But what do you notice about equation 4? All the coefficients are the same. That's a lucky break. So I'm going to use equation 4 to eliminate the y's from equation 5. What do I need to multiply equation 4 by to do that? Multiply by 26 over 11. That's just going to make it a little bit easier there. Could I have multiplied 5 by 11 and 4 by -26? Sure, but the numbers just get really big that way. I would just prefer to, not have to worry about those numbers getting so big. Let's see, -26y plus 26y is 0. -17 plus 26z is 9. -44 plus 26 is -18. If I divide both sides by 9, I get z is -2. I'm going to then plug that back into either equation 4 or 5. I guess given my choice, I'll pick it going into equation 4, since the coefficients are a little bit smaller there. So So I get a negative 11y plus 22 is equal to negative 11. Subtract 22 from both sides and then divide by negative 11. I get that y is equal to 3. Then I'm going to take that answer along with z equals negative 2 and plug that back into either equation 1, 2, or 3. It doesn't really matter which one, but I think equation 3 looks like the best option because the coefficient on x, that's what I'm going to be solving for, is 1. That saves me a little bit of hassle. So I'm going to plug it into 3. Would not be wrong to plug it into any of them. As long as there was 3 variables in it, it should be okay. But I like that I don't have to do any division. That's just like one less thing for me to make a mistake on. 12 minus 6 is 6. And if I subtract 6 from both sides, I get 1. Ah! What did I just do? Oh my goodness. So my solution would be the order triple 1, 3, negative 2. Phew. All right. So what happens if I get an infinitely many solutions situation going on, or a no solution situation in 3 variables? Well, no solutions is still going to be something like where you get 0 equals 1. Infinitely many solutions is still going to be something like when you get 0 equals 0. But we should talk about how to find the general solution for that then. So let's do an example to kind of run through how to do that. So I'm going to do an example here. So if I look at this system, would you rather do substitution or elimination? I would do elimination. Which variable would I want to do elimination on first? The z's. Yeah, because I noticed that if I add those two together, the z's cancel. And if I add those two together, the z's are going to cancel. And I don't really have to do any multiplying at all. That's like the best case scenario. So if I do that, I get 2x plus 2y is equal to 8. And then I'm going to get 4x plus 4y is equal to 16. We'll call those equations 4 and 5. At this point, you might notice that this is infinitely many solution situation, since equation 4 is half of equation 5. If you look at the coefficients. If you didn't, you could continue on and just do like negative 2 times equation 4 and add it to equation 5. If you didn't notice that straight away. Well, let's say we want to eliminate the x. So you multiplied equation 4 by negative 2. And now it happened to eliminate the y and the other thing at the same time. But I'm not trying to eliminate both variables at the same time. It just had to happen to eliminate one. I had to eliminate both. Right? So this is my indicator that there's infinitely many solutions. Right? Now, how do I get that general solution out of this? So what I'm going to do is I'm going to take either equation 4 or 5. It doesn't matter. I'm going to choose equation 4. And we're going to, with that equation, isolate one of the variables. Again, it doesn't matter which variable to isolate, x or y. I'm going to get the y by itself. So I'm going to subtract 2x from both sides, and then divide both sides by 2. Let's write it this way. So my general solution now is going to have like 3 parts to it, right? It's an ordered triple. The variable that I've written as the independent variable, in this case that's x, I'm just going to write as an x. The variable that I've isolated, I'm going to write as like 4 minus x, because I know y is equal to 4 minus x. To get my third component for my general solution, I'm going to take that equation, y equals 4 minus x, and plug it into either equation 1, 2, or 3. I'm going to plug it into equation 1 because the coefficient on z was 1 already, so it'll be easy to get z by itself. So I'm just plugging 4 minus x in for y into equation 1. When I simplify, I get the x's canceled out. That's unusual. That doesn't usually happen, but it can. And then to get the z by itself, I'll subtract 4 from both sides. So in this case, z is a constant. It's 0. So my general solution would be that ordered triple, x, 4 minus x, 0. Elise? Yep. Yeah. I would probably say that, tell you that this is a general solution problem and ask you to, like in infinitely many solutions, to find the general solution. Like I'd give you a little bit more than just like throw it in there.
Yeah.
Like I would tell you that this is what you're doing. But I think that's a perfectly fair question, right? Especially once you know it's coming, right? It's not a surprise now. Let's do that one more time because that's a little bit tricky, right? Probably helps to see it more than once. I think I have another one all set, ready to go. Yeah, that one. Okay. So if I look at this one, again, I would probably do elimination. I prefer elimination for all my 3 variable problems versus substitution. That's just me personally. But it certainly looks good for elimination to me. The variable I would choose to eliminate first is, what do you guys think? I would do a's because I notice equation 1 and 2 are already ready to eliminate the a's. And then what do I have to multiply equation 1 by so that when I add it to equation 3, the a's eliminate? 2. Yeah, excellent. Okay, so let's go ahead and do that now. So 1 plus Equation 1 plus equation 2 gives me 3b minus c equals 5. And then 2 times equation 1 plus 3 gives me 10 minus 7, so that's 3b. And then negative 4 plus 3, that's negative 1c. And then negative 2 plus 7 is 5. Wowzer, 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 wowzer. What do you notice here? Look at equation 4 and equation 5. What does that mean? I mean, clearly, there's just going to be infinitely many solutions since we have the exact same equation twice. Any attempt to try to eliminate one of the variables, you're going to eliminate everything. Everybody's cool with that? So save yourself the hassle, like you can just say IMS from there. But we still need a general solution. So again, our general solution is some ordered triple. What I'm going to do is I'm going to take equation 3 or 4. Well, since they're the same equation, I guess it doesn't really matter. And I'm going to isolate one of the two variables. Which variable is Mr. Kulik going to choose to isolate, C or B? C. Why? Because I don't have to do any division. I won't generate any fractions, right? Now, is it wrong to isolate the B instead? No, but like if you want to deal with fractions, that's on you. I'm not doing it, right? But just kind of for your reference that you could get an alternate answer by eliminating or by isolating the B, and that would be okay. We're not going to find it here because like I just don't want to deal with the fractions. All right. So the independent variable in this equation is B. That means like the independent variable in my general solution is going to be B. We're told that C is equal to 3b minus 5. So in the C place, I'm going to write 3b minus 5. And then to find A, I'm going to plug in that equation, C equals 3b minus 5, into either equation 1, 2, or 3. Which equation do you suppose Mr. Kulik's going to choose? If I'm looking to get A, I'm going to use equation 1 because, well, it's easy to get the A out of that. So in place of C, I'm going to plug in 3b minus 5. And I'm just going to isolate A. So I'll distribute that negative 2 through. Combine my like terms. And then I'm going to subtract 10 from both sides. And then add B to both sides. Here's a good question for you guys. How did I go from -1 to -11? I wrote down an extra 1? That's not right. That should just be -1 here. Should be -1 there. That should then be -11. And that should be an 11. Yikes! Look at how easy it was. Nobody even caught it when I did it. Maybe you did, but you didn't say anything, so you don't get credit for noticing. Okay. All right. One more technique to talk about, and then I'm going to leave you alone. That one other technique is called the triangular form. So okay, what's a system of equations in the triangular form mean? Well, let me give you an example. So here's an example of a system that's in the triangular form. Notice that the first equation we have 3 variables. The second equation we have 2 variables. The third equation we just have 1 variable. And the coefficients of the first variable in each equation is a 1. That's what we mean by something in a triangular form. So if I wanted to solve this, I already know the solution for z, right? Everybody's good with that? To get the solution for y, all I'm going to do is plug that answer for z into equation 2 and solve. So negative 5 times 1 is negative 5. I add 5 to both sides and I get 3. And then to get equation, or to get the x now, all I'm going to do is take those 2 solutions and plug them into equation 1. So I get x equals 1. And that was tremendously fast, right? Very easy to do that. Mr. Kulik, how come we haven't been doing that the whole time? Well, it's because getting something actually in the triangular form is not that easy. But once you got it there, solving is a breeze, right? Let's go and show you guys how we go about doing this, or getting an equation in the triangular form. And then I got some good news for you after we do that. So let's say we want to take this system and get this in the triangular form. So the first step is I need in equation 1, I need the first variable to have a coefficient of 1. Right now it's a coefficient of 6. What do you notice though? Look at equation 2. The first variable in equation 2 has a coefficient of 1. So all I'm going to do is swap the equations 1 and 2. So everything else stays the same, just we've switched the positions of equations 1 and 2. Right? No big deal there. So my next order of business now is I need to get rid of the x's in equation 2 and equation 3. How am I going to do that? Well, I'm going to do negative 6 times equation 1. I'm going to add that to equation 2. I'm going to make that my new equation 2. And then likewise, I'm going to do 4 times equation 1. I'll add that to equation 3. And then make that my new equation 3. Oops. So now my new system, equation 1, has not changed. Equation 2 is now negative 32y minus 14z equals negative 24. And my new equation 3 is now 28y plus 11z equals 21. Okay, next up I need to make the coefficient for y equal to 1. So it doesn't really matter whether I do that to equation 2 or equation 3, but neither of them are 1 already, so it doesn't really matter which one I choose. I'm just going to do it to equation 2. What do I have to multiply equation 2 by so that its coefficient goes from negative 32 to 1? How about just negative 1 over 32, right? So I do that, I get y, and then negative times negative makes a positive. 14 over 32z equals, again, negative times negative is positive, 24 over 32. Now notice that 14 over 32 reduces, as does 24 over 32. So my new system then is going to be, again, equation 1 has stayed the same. Once I have that set, it doesn't change. Equation 2 is now going to be set. Notice I have these yucky fractions. There's no getting around it. Well, it's okay. Make the best of it. Next shot, I got to get rid of that 28y. So to do that, I'm going to multiply equation 2 by negative 28, add it to equation 3, and make that my new equation 3. I'm going to reduce as I multiply. So negative 28 times 7 over 16, well, I guess that's going to be a negative number. 49 over 4. And then negative 21. And we have this. I don't know why I wrote y there. That's supposed to be a z in that spot. And let's see, that's going to be negative 5 over 4z. I made a common denominator. And then to solve that for z, I just get still z equals 0, right? So that's everything I needed now. My triangular system is this. And at this point, you're probably thinking, Mr. Kulak, why would I ever do this? Because this seemed way worse than just substitution or elimination was. Right? You guys agree? Yes, right? Here's the good news. This procedure is very easy to program a machine to do. And in fact, this procedure is already programmed into your calculator. So let's show you guys how to do this on your calculator. So let's take this same problem that we just did and we'll show you how to do this same problem on our calculator. Okay? If you have a calculator with you and you'd like to follow along, I encourage you to do so. I have a couple of extras here sitting on my desk if you don't have yours with you and you're like, I need to follow along on this. If you get home and you're like, shoot, I really wish I was paying more attention, I can't remember how to do this, you can always go back to the video at this point. We're at about, 50 minutes in or something. And you can watch it again. All right. So I'm going to start by inputting my system into my calculator. So to do that, I'm going to press second, and then the matrix button, which is just a little bit below the second button. Notice in blue above the x to the -1 is the word matrix. Once I open up that menu, you're going to see 3 different tabs, the Names tab, the Math tab, and the Edit tab. Now notice mine, A, B, C, D, all have stuff next to them. Probably yours are blank because you may not have ever done this before, but you might have. You might have some stuff there. It doesn't matter if there's stuff there or not. We're going to change whatever's in there in a second anyways. So I'm going to tab over to the Edit tab, and we're going to type this system into matrix A. So I'm going to press enter. Now if I look at my system here, I have a column for the x's, column for the y's, a column for the z's, and a column for the answers. So I have 4 columns. I have 1 row for equation 1, 1 row for equation 2, and 1 row for equation 3. So I have 3 rows. So the matrix that I'm going to create is a 3 by 4. Rows always come first, columns always come second. And then what I'm going to input in my matrix is, for the first row, I'm just going to type in the coefficients. So 6, -2, 4, and then 0, which I've already done here because I did this already once today. But I'm just taking the coefficients from row 1 and I'm inputting those as the entries in row 1 of my matrix. Guess what we're going to put in row 2? The coefficients from row 2. What's that first coefficient on the x? 1, right? Just because there's nothing there doesn't mean there's not a number, right? If there's a number in front of or if there's nothing in front of a variable, we understand that there's a 1 still there that we've chosen not to write for convenience sake. And then we do the same thing for row 3. So row 3 should be -4, 8, -1, 5. Pretty easy to enter that into your calculator. Not a big deal. Just plug in the coefficients, basically. What if you're short a variable? What if this last row was like -4x minus z equals 5? You'd put a 0 in the y spot. Exactly right. Yeah, perfect. You guys got it. All right. Once we've done that, we're going to press second, the blue button and the mode button right next to it to exit back to the main screen. So again, I press second and then the mode button, which is right next to it. I'm then going to go back into the matrix menu, so second and matrix. This time I'm going to go to the math tab that's right next to it. And I'm going to scroll down looking for the command RREF. That's the command on your calculator that has this triangular matrix thing already programmed into it. So I'm going to go ahead and press enter. And I'm going to do that to the matrix A that we just created. So I'm going to go back to the matrix menu. So second and then matrix. Select from the Names tab, matrix A, close my parenthesis, and press enter. So look at what this is saying. If I look at the first row, it says 1x plus 0y plus 0z equals 0.25. What's that the same as just saying? X is equal to 0.05. If I read row 2, it says 0x plus 1y plus 0z is equal to 0.75. Or just y is equal to 0.75. If I read the last row, 0x plus 0y plus 1z is equal to 0, or just z is equal to 0. Cheyenne? So you probably just typed a number in wrong when you put your matrix together. I would just go double check that all your coefficients are the same. There's probably one that you just goofed. And if you need, I can look at it in a second. It's totally fine also. All right. So at this point, we can do now all of the rest of the problems from the supplement. So I think, what are we up to? We did 1 through 8 last time, so we're now 9 through 34 or whatever is the rest of this. So that'll be part of Sundays. And then for the rest of the period, you can either work on the problem set, or we have a Delta Math assignment also. If you want to work on that, you could work on the Delta Math assignment, also do Sunday. So there's 4 kinds of problems. So solving a 3-variable system, they have level 2 and level 3. I don't know what the difference is going to be. I looked at them and there's nothing obvious that stood out between them. I'm guessing one of them you can get fraction answers and the other one you can't. But I don't really know. One where we're going to solve linear systems graphically. So you would make your plot your line. You can change it solid or dashed and decide which way you want to shade it. And then you make your other one or whatever. And then it wants a point. So like if this is the overlapping region, like 0, 0 would be a point in the overlap between, right? So you just type in 0, 0 and hit submit. Everybody's okay with that? Now, this is not the right answer to this one. I just put something on here to show you kind of how the inputs work. And then the last one is probably the trickiest one. So you have a story problem here. You're going to need to write some inequalities based on that story problem. There could be 1, 2, 3, or 4 inequalities. So you'll decide whether it's depending on how you want to do things. You could write it either way. You type in your equation, you press plot. The program's going to plot it for you, which is really nice. It'll draw the plot for you. And then you just decide whether the shade above or below. And then it's looking for, again, one possible answer out of that solution set. Okay? My suggestion to you would be to start with the Delta Math and maybe start with these graphing ones that getting it kind of figured out what the input looks like that it wants is maybe kind of tricky, because if you have questions on that, you can ask me and I can help you right away. You don't have to sit there and try to throw your computer through the wall trying to do it Sunday night, not get it to work. But it's up to you. The rest of the time today is yours, so the last 30 minutes or so of class we can spend working on these tasks. Cool? You guys are so excited. I love it.